Have you ever wondered if reality as you perceive it is just a thin layer of something far more complex, something so counterintuitive that even the brightest minds struggle to grasp it? Imagine for a moment that the universe you inhabit might not be the only universe, that every choice you make, every tiny fluctuation in your thoughts and perceptions could create a branching network of realities, each as real as the one you call home. This is not science fiction. It is a scientific idea, a proposition born from the most rigorous physics, quantum theory, and the philosophy of existence, a concept so mind-bending that it challenges the very framework of what we consider to be reality. Welcome to the exploration of the most mind-bending physics idea ever proposed, the multiverse, or more specifically, the many worlds interpretation of quantum mechanics, and its deep implications on our understanding of consciousness, perception, and the human brain. Physics, at its core, is the attempt to describe the universe in terms of its fundamental laws. Yet the laws themselves are often stranger than anything we can experience in our daily lives. Quantum mechanics, the theory governing the tiniest particles, reveals a reality that behaves probabilistically rather than deterministically, where particles exist in superpositions, multiple states at once until they are observed. The famous Schrödinger's cat thought experiment illustrates this beautifully. A cat placed in a sealed box with a quantum-triggered vial of poison is simultaneously alive and dead, at least until observation collapses the possibilities into one outcome. But what if observation doesn't collapse the possibilities? What if every potential outcome continues to exist in a branching network of parallel universes, each as tangible and vivid as the one we perceive? This is the radical proposal of the many worlds interpretation, introduced by physicist Hugh Everett in 1957. It suggests that the universe splits with every quantum event, leading to an almost infinite number of parallel realities. You might ask, why does this matter to us as human beings? Beyond the sheer intellectual thrill, this idea touches the core of who we are. Our brains, our perception of reality, and even our sense of self are rooted in interpreting probabilities, filtering sensory input, and constructing coherent narratives from a chaotic world of signals. Every decision you make, every fleeting thought, could correspond to a different path in this vast multiversal web. Neuroscience tells us that our brains are not passive observers. They are active constructors of reality. The concept of neuroplasticity, the brain's ability to rewire itself in response to experience, mirrors the quantum branching idea. Just as particles may exist in multiple potential states, neural networks adjust and adapt, exploring multiple possibilities in their pathways, until a coherent perception emerges. In a way, each of us embodies a miniature multiverse, our neurons dancing across potential connections, selecting outcomes that shape who we are. Consider stress and the way the brain reacts to it. The amygdala, the brain's alarm system, triggers fight or flight responses that prepare us to survive immediate threats. But this system doesn't just react. It anticipates. It models possible outcomes, simulating different realities within the confines of your mind. When you feel fear or anxiety, your brain is, in a sense, exploring multiple branches of potential futures, predicting consequences and outcomes, and selecting the safest path forward. Stress is not just a reaction, it is a computational process of reality simulation. And yet, our conscious perception interprets only a single trajectory, a linear narrative, even though the underlying processes are multifaceted and probabilistic, much like the quantum world itself. Perception, memory, and thought are similarly entangled with the idea of branching possibilities. Neuroscientists have demonstrated that what we remember is not a static recording but a reconstruction, influenced by attention, emotion, and expectation. Every recall is an act of creating a new version of the past, subtly shifting the neural landscape, and in doing so, generating yet another branch of subjective reality. This aligns uncannily with the many worlds concept. Just as the universe may branch with every quantum event, our minds branch with every experience, every memory reconstructed, every perception interpreted. The universe outside and the universe inside the brain reflect each other in astonishing ways, both governed by rules of probability, adaptability, and emerging coherence. The metaphors become almost irresistible. Imagine the brain as a vast energy network, neurons as nodes transmitting electrical signals, thoughts as oscillating waves rippling across this network. Each signal is like a quantum particle, uncertain and probabilistic, yet constrained by the architecture of the system. You, as a conscious being, are the observer network, interpreting these signals, collapsing the myriad potential states into a singular lived experience. Just as physicists attempt to decode the hidden structures of reality, neuroscientists decode the structures of perception. And just as quantum reality is more vast and strange than our senses suggest, the interior universe of your mind contains complexity and possibility beyond what you consciously experience. Now consider decision-making. Every choice you make may seem linear, logical, bounded by your understanding and circumstance. But what if each decision simultaneously unfolds across multiple realities? In one branch, you make one choice. In another, a different one. This is not just an abstract speculation. It has practical implications for psychology and our understanding of human agency. The brain's prefrontal cortex is constantly simulating potential actions and their consequences, effectively generating micro-branches of reality in anticipation of outcomes. Cognitive psychology describes this as mental time travel, the ability to imagine future scenarios, weigh them against past experiences, and choose actions. In essence, our minds are quantum simulators, exploring potential worlds before committing to a single path. This neural branching mirrors the cosmic branching of the many worlds interpretation, suggesting a deep resonance between physics and biology. The implications for identity are profound. If each decision spawns a branching reality, then the you that experiences this moment is one of countless versions, each existing in parallel universes. Neuroscience supports a multiplicity of selves even within a single brain. Different neural networks activate in response to different contexts, sometimes in conflict, sometimes in harmony, constructing a fluid, dynamic sense of identity. The human brain is not a monolithic self, but a constellation of interacting processes, echoing the multiverse in miniature. In a way, every thought you think, every belief you hold, is a universe in itself, a microcosm of branching possibility. What about consciousness itself? Could it be that consciousness is not confined to a single branch of reality, but rather has the potential to resonate across multiple branches? Some theorists speculate that consciousness might act as a stabilizing factor, a kind of observer that experiences one path while the multiverse continues to unfold around it. Others suggest that consciousness could be entangled with quantum processes, allowing information to propagate in ways classical physics cannot explain. While these ideas remain speculative, they challenge our fundamental assumptions about what it means to experience, to perceive, and to exist. The mind is no longer just a passive recipient of sensory data, but an active participant in the unfolding cosmos, a processor of probabilities, a navigator of infinite potentialities. This leads us to a counterintuitive twist. The moments when we feel weakest or most vulnerable may actually be when our brains are performing at their highest efficiency, safeguarding us in ways we cannot consciously perceive. When you hesitate, when fear paralyzes you, when indecision grips your thoughts, your neural circuits are running countless simulations, calculating the safest route through a complex landscape of possibilities. Stress and perceived weakness are adaptive. They represent the brain's capacity to anticipate, model, and protect, a reflection of evolutionary intelligence embedded in our neural architecture. The mind is both fragile and resilient, vulnerable and protective, a paradox that mirrors the very strangeness of quantum reality. Even time itself is not immune to these mind-bending considerations. Physics describes time as a dimension intertwined with space, flexible, relative, and in some theories emergent from deeper quantum processes. Our subjective experience of time, how it stretches, contracts, or seems to loop, is a reflection of the brain's predictive and reconstructive abilities. Memory, anticipation, and attention warp time in a manner that parallels relativistic effects, suggesting that our perception of causality and sequence is a cognitive construct, much like reality itself might be a branching network of potential events. When you recall a memory or imagine a future scenario, your brain navigates a temporal multiverse, threading a coherent narrative from countless possible sequences. These ideas converge in a deeply philosophical reflection. If the universe is a branching multiverse and the brain is a branching network of probabilities, then existence itself becomes a tapestry of interwoven possibilities. Each moment is a node of potentiality, each decision a fork in an infinite network of realities. The observer, the conscious self, is not merely witnessing this unfolding but actively participating, shaping probabilities through attention, choice, and interpretation. In this view, science and philosophy intersect. The cosmos is not just out there but also reflected in the architecture of our minds, and understanding one illuminates the other. Yet amidst all this complexity, there is an empowering insight. You are not a passive particle drifting through deterministic laws. You are an active agent navigating a sea of probabilities. Every thought, every act of reflection, every moment of learning rewires your neural circuits, adjusts your perception, and shapes your experience of reality. Just as the universe branches at every quantum event, your brain branches at every cognitive event, creating new pathways, new interpretations, and new possibilities for what you can become. In this sense, neuroscience and quantum physics converge to reveal a profound truth. Adaptation, creativity, and consciousness are emergent properties of a universe more intricate and astonishing than we can fully grasp. Now let us pause and consider a final twist. What if the constraints you perceive, the limits of your memory, attention, or intellect are not failures but safeguards? The brain filters, abstracts, and simplifies, creating a coherent self from a torrent of possibilities. Your limitations are, paradoxically, the framework that allows you to function, to navigate reality, and to perceive a world that is comprehensible. What you think of as weakness is often the brain optimizing for survival and coherence, pruning infinite possibilities into a manageable experience. In this light, the strangeness of the universe and the strangeness of your own mind are reflections of the same principle, the interplay of complexity, probability, and emergent order. In conclusion, the most mind-bending physics idea ever proposed, the many worlds interpretation, does more than challenge our understanding of reality. It illuminates the intricate parallels between the cosmos and the human brain. Our neural architecture, our perception, our sense of self, and our decision-making processes are microcosms of the probabilistic branching universe described by quantum mechanics. The brain is not merely observing reality, it is actively participating in its unfolding, navigating countless possibilities and collapsing probabilities into lived experience. Each moment is a convergence of cosmic and neural branching, a point where physics meets perception and science meets philosophy. So the next time you find yourself hesitating, imagining, reflecting, or dreaming, consider this. You are not merely reacting to a linear reality, but engaging with a vast network of possibilities, your mind echoing the complexity of the universe itself. Each thought, each choice, each perception is both profoundly ordinary and astonishingly extraordinary, a reflection of the boundless potential of the cosmos and your own consciousness. And as you ponder this, ask yourself, if the universe branches endlessly, and the mind is a multiverse in miniature, what realities are you actively creating with your attention, your curiosity, and your choices? How might your understanding of possibility expand if you truly grasped that every moment holds countless potential worlds within it? If this exploration sparked new ways of thinking, new questions about the nature of reality, or a sense of awe at the complexity of existence, please take a moment to like this video, share it with someone curious about the cosmos, and subscribe to MindSpark Science for more journeys into the frontier of physics, neuroscience, and philosophy. The universe is not just around you, it is inside you, branching with every thought, every perception, every decision. Embrace the wonder, question everything, and keep exploring.